Welcome. This is a video on derivatives of inverse functions. Now for finding derivatives of inverse functions, there's two ways of doing it. One way is called the derivative rule for inverses. And then the other way, which I usually recommend to students, is to just find the inverse first and then take the derivative of the inverse. Okay? So there's two methods. Two methods or two different approaches. The first way is called the derivative rule for inverses. Derivative rule for inverses. And this is a little bit of a complicated rule that you can use. Some people use it. I don't usually recommend using it because it ends up being more work, but I'm going to write it down anyway in case you ever need it. So it just says that the derivative of f inverse of x, so f inverse prime of x, is equal to 1 over f prime 1 over f prime of f inverse of x. So the idea, if you did want to use this derivative rule for inverses, is you would go ahead and you have to first find f inverse of x, then you have to find f prime, and then you have to plug in f inverse into f prime, into the derivative, and then you take the reciprocal. So reciprocal 1 over just means you flip the fraction over. Now in most cases, this is a lot of extra work, because think about how many things you would have to do here. First you find the inverse, then you find the derivative, then you plug in the inverse into the derivative, and then you take the reciprocal. That's a lot of steps. So I don't usually recommend using this derivative rule for inverses. Sometimes if they give you numbers to plug in, it might be necessary to use it, but in most cases, this is a bad idea. Okay, so not usually recommended. Usually more work. And we don't want more work, right? We want the math to be as quick and simple as possible. So I usually don't recommend using this. So instead, what I recommend for most problems is first you find the inverse, then you take the derivative. Okay, so you find f inverse, then take the derivative. Now there might be some very rare, weird problems that you might see on some people's homeworks, not in my class, but maybe in some other classes, where teachers manage to find a problem where the only way to solve it is using the derivative rule for inverses. But in most cases, you don't actually need to use this, and this is more work than what I was just saying, which is just to first you find the inverse, then you take the derivative of that inverse. So you take the derivative of f inverse. So in most cases, method number 2 is usually recommended. And because in my homework and on my test, I don't have any super tricky problems where we would have to use the derivative rule for inverses, I'm not going to teach using this derivative rule for inverses because I think it's clunky and it only has very rare applications where you have to use it. But in most cases, and for my homework, my quizzes, and my tests, we're just going to be using this approach because it's it's way quicker and it's easier in most cases. Okay, so we're going to stick to method 2, and then let's jump into an example. Okay, so example. Example. Find a formula for df inverse dx. Find a formula for df inverse dx. All right, and note df inverse dx, that's the same as what I was writing above. So this is the same as f inverse prime of x. Okay, so it's the derivative of f inverse. So we're going to be using method 2 because, once again, it's usually recommended because it's a lot less steps, a lot easier, a lot faster in most cases. So that's what we're going to be doing. Okay, so for problem number 1, our function f of x is going to be 1/3 x plus 5 over 6. 1/3 x plus 5 over 6. Okay, so using method 2, like I said, first you find f inverse, then you take the derivative of f inverse, and that's the whole problem. Okay, so let's start with finding f inverse. So make sure you've watched my other video on how to find inverses before you watch this one, because we're going to be using that information here. So first step is find f inverse. So to do that, remember you replace f of x with y. So we have y equals 1/3 x plus 5/6. That's your first step. And then the second step is to interchange or switch the variables x and y. Okay, so we're going to switch x and y, but remember you don't move anything else around. You're not moving the 1/3, you're not moving the 5/6. You're only interchanging the variables themselves. Okay, so what we get here is x equals 1/3 y plus 5 over 6. Okay? So here I'm following the steps for finding the inverse that I described in detail in the other video, in the previous video. Okay, so we interchange x and y, and then we solve for this new y. Okay, so to solve for y, first of all, we have to get rid of the 5/6 to get y by itself. Okay, so we're going to go ahead and subtract 5/6 from both sides. Okay, so we minus 5 over 6 from both sides. Okay, so then on the left side, we get x minus 5 over 6. And then on the right side, we have 1/3 y. Okay? And then to finish isolating y, we're going to have to get rid of the 1/3. Now remember, to get rid of a fraction multiplied times something in an equation, you multiply both sides by the reciprocal. Okay, so we're going to multiply both sides by the reciprocal of 1/3, which is the same as 3 over 1. So I'm going to multiply both sides by 3 over 1. Okay? Because 3 over 1 is the reciprocal of 1/3. So on the right side, the 3's cancel and we just get y. And then on the left side, when we distribute the 3 to each term, we're going to go ahead and get 3x for the first term, because remember, 3 over 1 is just the same as 3. If your denominator is 1, you don't have to write it. And then for the second term, we have 3 3 over 1 times 5 over 6. And remember, to multiply fractions, you just multiply straight across. Okay, so you multiply the numerators, and you multiply the denominators, and then you simplify. Okay, so like here, we're going to go ahead and cancel out the 6 and the 3. So if we divide the top and the bottom by 3, the 3 on the top goes away, and then on the bottom, we get 2. All right, so after we do all that, we're going to end up with 5 over 2. All right, so we're going to have minus 5 halves. So we have 3x minus 5 halves equals y. Okay, because 6 divided by 3 is 2, so that's how we got a 2 in the denominator. Okay, and then remember at the end here, this y that you get after you switch x and y, this new y is actually f inverse. Okay, so now we have a formula for f inverse. So we have f inverse of x equals 3x minus 5 over 2. Okay, so far so good. So we did our first step, which was actually to find f inverse. And then, like I said, your second step, if you're using method 2, which I usually recommend, is you take the derivative of f inverse. Okay, so that's what we're going to do next. So step 2 is going to be to take the derivative, of f inverse. So literally all we're going to do here is take the derivative on the right side. So taking the derivative of both sides, we're going to get df inverse dx is equal to, well, hopefully you remember your derivatives from Calculus 1. But basically, if you have a variable times a constant, and it's just a variable with no power or a radical, the variable goes away when you're taking the derivative. So the derivative of 3x is just going to be 3. Okay? So we're going to have a 3 for the first term. The x just goes away when you're taking the derivative of x with no power, no square root, nothing fancy, no fractions. Okay, so that's just going to be 3. And then for the second term, the derivative of negative 5 over 2 is 0. Because remember, the derivative of any constant is always 0. Okay, so this negative 5 over 2 just goes away and we get 0. Okay, so that actually means df inverse dx is equal to 3. Okay, and that's our whole answer. That's the answer to the problem. Okay, now you're welcome to use the derivative rule for inverses. I'm not going to do any examples of it because it just ends up confusing people. And on the vast majority of problems, it's way more work, it's way clunkier, and it's way more confusing. It just has more steps in most cases. Now, if you end up needing it in a later class at some point, you can always use it then. But in those cases, if you have a special problem where you have to use this thing, which are very rare, basically you would just find the inverse, then you would take the derivative of the original function, then you would plug in the inverse into the derivative of the original function, and then you would take the reciprocal. But that's a lot of steps, so we're going to not do that, because in most cases that's just a bunch of extra work, and it's just more confusing. Okay, all right, so that was our first problem, and I wanted to do a couple more. So if you need more help finding inverses, remember I have my last video, I did a couple of problems where I find inverses. But here I'm going to try to focus on problems that are a little bit different from my earlier video, since I already talked about how to find the inverses of those problems. Okay, so let's see problem number 2. Okay, problem number 2. For problem number 2, f of x is equal to 729 x cubed. Okay, and once again, they want us to find df inverse dx, in other words, f inverse prime of x. Okay, so once again, I'm going to be using method 2 because it's just quicker in most cases and easier. So our first step is going to be to find f inverse. Find f inverse. Just move that up a little bit. Okay, so remember, to find f inverse, your first step is to replace f of x with y. Okay, so we get y equals, oops, wrong color here. Y equals 729 x cubed. Okay, so you replace f of x with y as your first step. Your second step is always to interchange or switch the variables x and y. And once again, you're only switching the letters. You're not switching anything else. You're not moving powers or numbers or anything, just the letters. So we're going to have x equals 729 y cubed. Okay? And then, of course, our goal, whenever we have y in an equation, is to isolate y. So to isolate y here, first of all, we need to get rid of the 729. So in order to do that, we have to divide both sides by 729. So let's divide both sides of the equation by 729. Okay? So after we do that, we're going to wind up with x over 729 equals y cubed. Okay, and then what do we do next? Well, we still have an isolated y. We have to get rid of the cube. Now remember, to get rid of a power, the best way to do that in an equation is to isolate the power, which is what we've done, and then to take the root of both sides. And your root is going to depend on your power. So here, because our power is a cube, we're going to be taking the cube root of both sides. Okay, so we go ahead and we take the cube root of both sides of the equation. And remember from my last video that when you're taking an odd root like this, you don't need to write a plus minus. Okay? So for odd roots, you never write a plus minus. So since 3 is an odd number, we don't need to write a plus minus. Okay? So on the right side, the cube root and the cube cancel out. So we just get y. So we get y equals cube root of x over 729. Now remember, if you have a radical applied to a fraction, you can actually distribute the radical to the top and the bottom. I don't know if you remember that, but you are allowed to do that. So I can distribute this cube root to the top and the bottom. So on the top, I'm going to have cube root of x, and then on the bottom, I'm going to have cube root of 729. Okay, and then cube root of 729 might be difficult to do in your head. You could factor it, or you could just use a calculator. And for my course, if you don't have an actual physical calculator for whatever reason, you're always welcome to use online calculators, or even just the one that is on your computer, whatever one you have on there. So if I do 729 to the 1/3 power, remember the 1/3 power is the same as the cube root. 1/3 power. Did I do that right? I don't think I did that right. 729 to the 1/3 power. Oh no, wait, maybe I did. That's 1/3. That can't be right. Oh well. Maybe I'm not using this calculator correctly. 729 to the 1/3 power. Well, it's saying it's 1/3. It's saying it's 0.333, which is 1/3. Okay. Well, I guess it's 1/3 then. So we have y equals cube root of x divided by 1/3. Okay, and then 1/3, when you take the reciprocal of that, you flip it over. That's supposed to be an x up there. When you take the reciprocal of 1/3, that becomes 3. So I can move that 3 up to the top. Okay, so we actually have y equals 3 times cube root of x. And if you have a calculator that will simplify radicals, that's also something that can be helpful sometimes. So for example here, if you didn't want to write it as 1/3 power, you could also factor 729. I don't know what goes into 729, but you can just play with the calculator to do that. So for example, you could do 729 divided by 3. Oops, wrong button. 729 divided by 3. And that's 243. And then you could go like that. And then simplify the radical that way. But I just took the cube root and it gave me 1/3. So I just went ahead and wrote that as 1/3. Okay, so remember this new y that you get here is the same as f inverse of x. So we have f inverse of x equals 3 times cube root of x. Now if you get big numbers like 729, again, if you want to simplify the radical, you can actually make a factor tree. If you can't just plug it into the calculator and get a fraction. So for example, we could have made a factor tree for 729. And I discovered that 729 divided by 3 is 243. So that would mean 729 is 3 and 243. And then, for example, you could factor the 243. So again, it's not in your times tables, but you could try dividing 243 by numbers like dividing it by 3, and it gives you 81. Okay, so 243 is 3 and 81. But this way is a bit more tedious than just plugging it in and getting 1/3. But anyway, 81 would actually be 9 times 9. We should know that from our times tables. And then each of those 9s would be 3 and 3. 3 times 3. So we have 3 times 3 here and 3 times 3 there. So after you do all of that, you notice that you have a total of 1, 2, 3, 4, 5, 6 3s. So that means 729 is actually equal to 3 to the 6th power. Okay? And then when you take the cube root of that, so if I take the cube root of 3 to the 6th, that's the same as 3 to the 6th raised to the 1/3 power. I don't know if you remember that, but if you have a radical, you can turn that into a rational exponent where the denominator of your exponent is the same as that type of radical. So that would be 3 to the 6th to the 1/3, and then you just multiply these exponents. Okay? And so that's going to be giving you 3 to the 6 over 3, which is 3 squared, which is 9. I'm not sure if I used the calculator correctly with the cube root. Maybe the one on the computer is not working so great. I don't know if I pressed the wrong button or what, but anyway, what we get there is that the cube root of 729, is actually going to be 9. I wonder why that didn't work. Well, I guess this calculator here is a little bit funky. Let's see. Maybe if I put parentheses around it, it'll work better. So 729 raised to the 1/3 power. Oh, there we go. Apparently I didn't press equal. Well, there we go. That makes more sense. So it wasn't actually 1/3, it was actually 9. I'm just trying to learn how to use this calculator here on the computer. This is what came with my computer. Okay, anyway, but this is just math. You know, I'm going to leave all this in the video just so that you can kind of learn how it is to get familiar with calculators. It's not always immediate, right? Okay, so I'm not going to redo this video. I'm just going to leave this in here so you can see how to use a calculator and also to have the failures and then realize, oh, what I did wrong. So apparently I just didn't press equal at the end, so that makes sense. Okay, so what we got here is either using a calculator or a factor tree like this and simplifying it, we're going to get that the cube root of 729 is actually 9. So I was wrong over here, but it's a good thing I checked it. So this cube root of 729 is actually 9. Okay, so we have a 9 down here. So now we have cube root of x over 9. That's kind of funny. And if you have a physical calculator, that might be more reliable than some online calculator or the one that comes with your computer. But it's nice to know that even the one on your computer can work. It's just a little bit finicky. Okay, so what we got here is f inverse of x is cube root of x over 9. Now, that was our first step. That took longer than it should, but that was because I was playing around with the calculator. So we found our f inverse. So what we're going to be doing next is we're going to go ahead and take the derivative. Okay, so step 2 is take the derivative, or find the derivative of f inverse. But I checked my work, so we should be good now. We have the correct formula for f inverse. So then we're just going to be taking the derivative of this. Now once again, remember that a cube root is the same as an exponent of 1/3. So I'm going to go ahead and write this as x to the 1/3 power, just to make it easier to take the derivative. So on the top we have x to the 1/3, and then on the bottom we have 9 for our f inverse of x. And then to take the derivative of a power, I don't know if you remember the power rule, hopefully you do from Calculus 1, but basically to take the derivative of a power, you bring the exponent out front, so you bring it in front of the x, and then you decrease it by 1. So we're going to be doing 1/3 minus 1. So after I bring the exponent out front, I have 1/3 x to the 1/3 minus 1. So what is 1/3 minus 1? 1/3 minus 1 is the same as 1/3 minus 3/3, because remember, you can multiply the 1 by 3 over 3 so that they have the same denominator here. And then 1/3 minus 3 over 3, just subtracting on the top, 1 minus 3 is negative 2. So we actually get negative 2/3. Okay, negative 2/3. Alright, so our new exponent, after we decrease it by 1 using the power rule, is negative 2/3. And don't forget, we also have a 9 on the bottom. And instead of writing the whole thing over 9, what I'm going to do is I'm going to rewrite it as a 1/9 out front. So I'm actually going to have a 1/9 out here. So we have 1/9 times 1/3 x to the negative 2/3. Okay? And then from there, all we have to do is really multiply these fractions. And once again, remember, when you're multiplying fractions, you multiply straight across. So you multiply the numerators and the denominators. So 1 times 1 is 1, and 9 times 3 is 27. So I get 1 over 27 x to the negative 2/3. And make sure when you're doing your homework and your quizzes that you practice with whatever calculator you do use, even if it's just the one that's on your computer, like the one I was using here. And if you want to have a better calculator, you can use GeoGebra. That's a good one online. And that one's free as well. I believe Mathematica or Wolfram Alpha are really good calculators. There's lots of other ones online. Or if you have a physical calculator, scientific, a good one would be the TI-30XS. And then for graphing calculators, I usually recommend the TI-89 because that one will actually do sine and cosine as well as simplify radicals for you. So the TI-89 is probably the best, one of the best graphing calculators. And it'll also do graphs, which will let you see if a function is one-to-one right away. So that's a nice one to have. But you can do the whole course with just the calculator that's built into your computer, or just a cheap calculator, one that's on your phone, you know. So it's still possible to do it all without a fancy calculator. Okay, so what we got here is, this is our F inverse prime, right? So we took the derivative here. So this thing right here is F inverse prime of x. In other words, this is dF inverse dx. Okay, dF inverse dx equals 1 over 27 x to the negative 2/3. All right. And let's see, looking through your homework, the rest of this stuff doesn't look too bad. I think I'll just do one more. They're mostly power rule problems in your homework. Those are the best ones I could find on MyMathLab, which is the program we're using here. Okay, so for problem number 3, we're just going to do one more. Problem number 3. We want to find a formula for dF inverse dx, where f of x is equal to x to the 23 over 5. F of x equals x to the 23 over 5. All right, so once again, I'm going to be using method 2, which is just usually quicker than the derivative rule. So we're going to first find f inverse. So to do that, we replace f of x with y. So we get y equals x to the 23 over 5. Okay? Next step is to interchange x and y. So we're just switching the letters. We're not moving anything else around. So we get x equals y to the 23 over 5. Okay? And then we want to solve for this new y. Now, how do we solve for this new y? You might not be sure how to solve something like this. 23 over 5 is kind of a strange exponent, and what we want is we want to just have y on the right side. Well, as weird as this sounds, you can actually just go ahead and raise each side to the reciprocal power. Okay? So we're going to take the power of both sides, and this power is going to be the reciprocal of 23 over 5. So I'm going to raise each side to 5 over 23. Now you might be wondering, well, how can you do that? Are you allowed to do that? Well, it's an equation. So as long as you're doing the same thing to both sides, and you're not losing any information, you should be okay. So this denominator is odd. So this odd denominator means that there's no plus minus. So there's no plus minus, because remember, this is actually a radical. And the denominator determines what kind of radical it is. So this is actually a 23rd root. So keep in mind that something to the 5 over 23 is actually the same as the 23rd root of that to the 5th power. Okay, so it's a little strange to have the 23rd root, but the 23rd root actually means, so for example, if I said a to the 1 over 23, that's the same as the 23rd root of a, is what I'm trying to say. And because 23 is an odd number, that's an odd radical, we don't need a plus minus. Okay? So because we don't need a plus minus, we can literally just raise each side to the 5 over 23, the fifth power over 23. And remember, if you're raising an exponential to a power, you just multiply the exponents. So here we're going to have x to the 5 over 23 on the left side. And then on the right side, we're going to have y to the 23 over 5 times 5 over 23. And that's the whole reason why I raised both sides to the reciprocal power. Because I knew that I was going to multiply these exponents, and I knew that what happens now is when I multiply straight across, the 5's cancel out and the 23's cancel out. So we actually just get y. And I know that algebra is a little bit tricky here, but once you get used to it, this is actually a pretty easy problem. It's just a matter of understanding how to do it. Okay, so what we got here is on the right side, we just have y to the 1. Okay, and y to the 1 is the same as y. So we have y equals x to the 5 over 23. All right, and then remember, y, this new y that we've come up with here, is the same as f inverse. Okay, so our f inverse of x is equal to x to the 5 over 23. All right, so we did our first step. We found f inverse. Now our second step is going to be to take the derivative. Okay, so take the derivative, and that will give us our df inverse dx. Okay, so taking the derivative, this one isn't too bad to take the derivative of. Basically all you have to do here is the power rule. Okay, so remember with the power rule, you bring the exponent out front. So the 5 over 23 comes out front. And then you decrease the exponent by 1. So you subtract 1 from the exponent. Okay, so we're actually going to have 5 over 23, 5 over 23 minus 1. Okay, and then building these to the same denominator, remember that 1 is the same as 23 over 23. So we have 5 over 23 minus 23 over 23. Okay, what we're doing here is we're trying to decrease the exponent by 1. So in other words, in this exponent right now we have 5 over 23 minus 1. And that's going to be the same as 5 over 23 minus 23 over 23. And 5 minus 23 should be negative 18. Is that right? You can always use your calculator. 5 minus 23, negative 18. Okay. So we've got negative 18 over 23. Okay, so that's going to be our new exponent. All right, and that's going to be the problem. So what we've got here is df inverse dx equals 5 over 23, 5 over 23 times x to the negative 18 over 23. The arithmetic and the algebra are a little bit obnoxious on this problem with all the fractions, but other than that, hopefully it's not too bad.